You're watching Power Nation.
Today on Engine Power, it is round 3 of the shootout between our 302 small block Ford and our 305 small block Chevy. Now, everything is going to stay the same for round 2, except for one major change.
And that is compression. Last time there was a discrepancy between the two and the internet, and you guys went bananas. So we got them back to a level playing field to see how it affects both engines.
It's going to be big. Hey everyone, welcome to another extremely fun day here in Engine Power because this is round 3 of our 302 versus 305 shootout. Now this has been a multi-stage process of comparing a small block Chevy 305 and a small block Ford 302, and quite honestly, this has lit you guys up.
Last time, just because of the way it worked out on parts, there was a discrepancy on compression ratios. So today what we're gonna do is we're gonna get them back to a level playing field. We've got pistons that are for it, and they're gonna get in there, and they're bringing them back to exactly the same, as close as we can get it in compression ratio.
Because we've got a lot of work to do. We've already gone ahead and torn both engines down. So while we get the rest of this stuff cleaned up, here's a look at rounds 1 and 2 and everything that has already gone into these power plants. This multi-part series has been all about comparing the two most popular and readily available small displacement small blocks to see how they stack up as budget-minded upgrades are installed in stages.
For the first set of upgrades, we kept the heads and bottom ends intact and kept the mods as close as humanly possible to keep it fair. These included aftermarket hydraulic roller camshafts using the same lobes and virtually identical specs, new timing sets, roller lifters, valve springs, the same style intakes, the same carburetor, new matching ignition systems, and the same style and size of header. Given similar displacements and upgrades, the engines made the same power numbers at 302 horsepower and 328 pound-feet of torque.
Round 2 was by request from you, our viewers, and for this set of upgrades, we swapped the original cylinder heads. The 305 received a set of later model 059 casting 305 Vortec heads, and the 302 received the famous GT40P heads. Both engines also got aftermarket roller rockers, and since the Vortec heads use a different intake style, both intakes were swapped again to make sure they stayed similar.
All the other parts remained the same and were reused on both engines, and the results showed in the dyno. The 302 jumped up to 344 horsepower and 339 pound-feet, while the 305 still had gains but lagged behind at 326 horsepower and 318 pound-feet of torque.
So like we said, we're going to be changing the pistons. So the first thing we're going to do is remove the pistons from the rods, and they use a press fit wrist pin. So what that means is that the wrist pin actually has about 1,000 or 10,000ths of an interference with the rod bore, and that is what captures the pin and captures the rod inside the piston. It doesn't use spiral locks or circ clips or anything like that. For what we do, we usually use a very dedicated tool to remove piston pins. This is one made by Goodson, and this is actually really, really nice because the way it works is it actually uses this little U slot here to support the rod itself. So none of the force is actually exerted onto the piston. You can press the piston off without damaging it and reuse it if you need to. Okay, so we have all of our old pistons pressed off. So now it's time to show you what the new stuff that we're going to be putting on. And if you didn't know, it is a little tricky to get two completely different engines very, very close on compression ratio, but we reached out to UEM because they have an extremely wide line card and a couple different lines of pistons, so we were able to do some picking and hunting and actually find two pistons, one for each, that will get us extremely close. So we have an Icon piston and we have a KB piston. These are two different lines that UEM offers. For the Ford, we're going to be using an Icon piston, so this is a forged 2618 piston. It has a 1.608 stock compression height, but it has a 6.8 cc effective dome, which compared to our flat top is going to give us a big bump in compression. For ring pack, it has a 16th, 16th, 3/16 ring pack, has a nice coating on the skirts. It's a very nice, very well machined forged piston, and we're going to use it with our press fit rods again. For the Chevy, this is a KB Hypereutectic piston specifically for a 305 application, and this too has a slight dome to it. It is a cc dome with some pretty hefty valve reliefs if you're running big cam stuff. For this one, it has a 5/64, 5/64, 3/16 ring pack, so very close, very similar. It's a very, very nice casting, very well machined, just like the Icon. So we have these ready to go, but we need to prep the blocks. So when we come back, we're going to hone both blocks and balance both cranks to get these engines ready for assembly.
Coming up, we get our 5 liters honed to size, balanced to perfection, and then these projects start heating up. All right, now it's time to get these engines out to their final bore size, which is 30 thousandths over on both of them. We don't need a boring bar to do this. Our Sun and SV15, we have accurate and very rigid diamond abrasives that will keep the engine's bore in check very, very well. This, in fact, is going to take about 22 to 24 minutes per cylinder to get it out to the size it needs to be. So 16 cylinders, that means I got a lot of work to do. We are starting with the 305 block and are using a 150 grit roughing abrasive from Sunnit to remove the large amount of material as quick as possible and make sure the final product is round and straight. Tackling one side at a time, we run the bores out almost to final size with a torque plate installed before switching the abrasives for a set of 600 grit to set our final surface finish. After verifying the work and documenting our measurements, the Chevy is finished up and we can get it out of the hone and get ready for the 302.
Okay. For the crankshafts, we are going to check the balance on our multi-bal 5500 from CWT. We're probably going to have to make some small adjustments to both, but we have cleaned both cranks, and the first one to go in is going to be the Ford because it's a little more involved because it's externally balanced on the rear and the front. So we have a 50-ounce flywheel on the back. We have our damper installed on the front. We have bob weights already made, and we know our piston is a little bit lighter than the old one, so we're going to spin it and see what we get. This process should be pretty straightforward on this crank, and after determining our initial imbalance was under 4 ounce-inch for each side, we were able to use a variety of drill bits to remove the material needed from the counterweights. Soon we have the crank dialed in with a very low imbalance at 0.099 ounce-inch on the rear and 0.129 ounce-inch on the front.
Back at the hone, we have our 302 block in place and are starting the roughing process on the first bank to get the cylinders out to size. The process is very similar to the Chevy, but since we are using a forged piston for this engine, the piston to cylinder wall clearance has to be significantly larger to accommodate the increased thermal expansion of the piston. It is to be noted that both engines receive the same crosshatch angle at 39 degrees and the exact same surface finish profile.
All right, we have our 305 crank in the balancer now, and this is internally balanced, so we don't need the flywheel or the damper when it's in the balancer. Now, the weird thing about this one is that it wants us to remove the weight from the rod journal itself. Now, normally we remove the weight from the counterweight side. This one is inverted, so normally you would have to add weight to the counterweight and then remove it again, but because it is such a low amount of weight, what we're actually going to do is something a little bit different. We are going to drill holes into the rod throw itself. So this one doesn't have it from the factory, but that will be a quick and easy way to get our 6 grams out, and holes aren't going to have to be that big, so at this power level and this RPM, it's going to be just fine. We'll get this one tuned in just like that Ford. This little casting boss on the front crank throw is removed first and the surface smoothed out to make the drilling easier. After getting a small starter hole made, we can incrementally step up the drill size until we have removed the mass that's causing our imbalance, checking our work as we go. The process is repeated on the rearmost crank pin, and the crank is checked until we reach our balance target. All right, that is going to be plenty good. We are 0.153 ounce-inch on the left, 0.146 ounce-inch on the right. So that is well within our tolerance. We got them nicely matched, nicely separated, and we'll save that as our last spin. And it sounds like Pat is almost done with that block.
That's right, I just finished up the 302 block, and now we have fully machined blocks and cranks that are ready to hit the cleaners. In the meantime, we are going to do our last machine shop process, installing the new pins on our press fit rods, which we can do in-house with our Goodson propane rod heater and pin setting fixture. The small end of the rod is heated up for about 20 to 30 seconds in the flame until it just starts to change color, and then there's a short amount of time to install it with the pin and piston before it cools and regains its interference fit.
The process is relatively simple, but needs to be done correctly, or you can improperly install the pin and potentially damage the rod end and or piston. So no matter what you've seen on the internet, it's probably an operation best left to a machine shop. Up next, our small blocks go back together on the cheap and get ready to duke it out in the dyno.
We are diving into the reassembly process on both engines, starting out with the crankshafts, which are laid into our bearings coated with Hot Shot Secret assembly lube. Both engines received new rod and main bearings while they were apart, and we already have measured all of the oil clearances. With the thrust faces properly aligned in the forward position, the main fasteners on both are torqued to 65 pound-feet.
The camshaft bearings on these engines were in surprisingly good condition, so the Comp Cam's Extreme Energy camshafts can be reinstalled. Both cams use the same series of lobe, and they have durations at 50 thousandths lift of 218 on the intake and 224 on the exhaust with a 110-degree lobe separation angle. They vary slightly on lift, with the Ford having 546 thousandths of an inch of valve lift on the intake and exhaust, and the Chevy having 528 thousandths on the intake and 536 thousandths on the exhaust.
The Summit Racing adjustable timing sets are reinstalled in the exact same positions and torqued in place, but we will still verify the camshaft's position by installing the #1 piston in each engine and degreeing the cams. The Ford is set on 105 1/4 degree intake center line, and the Chevy is set at 105.5 degrees.
The remaining 7 piston and rod assemblies are installed next. For the Chevy's smaller 3.7 66-inch bore, we'll use an adjustable ring compressor that will square up against the decks that have been freshly cut to 9-inch by Shacklet Automotive Machine, and each of the pistons and rods are temporarily tightened down during installation until they're all in, and we can go through to torque each rod bolt to 45 pound-feet. This Summit Racing 4030 piston ring compressor and dead blow piston hammer ensures a smooth installation with the Ford, and the 5/16 rod bolts are torqued to the factory spec of 24 pound-feet.
Since both engines got new front seals in round 1, we only need to replace the timing cover gaskets, and since both the Ford and the Chevy use factory doweled timing covers, they can be cinched down with a film of silicone. Because budget is the name of the game, we will also reuse the factory dampers and have verified their timing marks. They are installed with the proper damper installer. Next is sealing up the bottom end. Both oil pumps have been inspected. Since they had very good oil pressure, the Chevy's pump can be put back in with the factory drive shaft and torqued down to 65 pound-feet. A new one-piece gasket is placed on the engine and the oil pan is dropped on and tightened down with the stock hardware. The Ford follows with the factory pump and drive shaft going in before the pump and pickup are torqued in place with thread retaining compound. It also gets a one-piece oil pan gasket before the pan is dropped on and cinched down tight.
Since the Ford's lifters have to be installed before the cylinder heads, we can lubricate and reinstall them now with the factory dog bone retainers. Once they are all in, the lifter tray is dropped on and torqued in place. The Chevy lifters will also be installed, but since they are a retrofit link bar style, they can just be lubed and slid in. Okay, we are ready to put our cylinder heads on, but you've probably noticed a slight change in the top of the piston because we are using the GT40P heads. This is a very unique design, and basically the spark plug boss is moved, it has a different angle and is moved towards the center of the chamber, so it protrudes much deeper than a normal conventional Ford head would. We actually had to do a slight clearancing to the spark plug boss itself inside the cylinder head, and on the piston we had to cut a relief. Looks like a big cut, but actually this is not that much. It's about 2 cc's. We had a really great piston fixture from Summit Racing, so we were able to do a very accurate, very consistent cut. And this is something that just is very specific to these cylinder heads. If you were doing a conventional Ford head with an open chamber or an aftermarket head, this really wouldn't be an issue, but we also had to do something similar to the Chevy.
Yeah, we had a similar situation on the Chevy, not quite to the extent as the Ford. We had this little boss in the cylinder head that protruded into the dome. So what we did is just made a smaller cut, but still pretty significant. We had to do rights and lefts because remember, Chevy has different looking chambers, so it didn't affect the effective dome that much, but it did reduce its volume a little bit. So we have a clearance cut on there. We didn't have to do anything to the cylinder head, but we got them all scienced out and they're gonna work great.
Affordable head gaskets were used on both engines, and the Blue Oval is using a 4100 bore 38 thousandths compressed thickness composite that puts the measured static compression ratio at 10.91 to 1 with its 58 cc chambers. The head bolts are installed with thread sealer on the threads, since some of them protrude into the water jacket, and they are all torqued to 65 pound-feet.
The 305 head gaskets are Chevrolet Performance composites with a 4/100 bore and a 28 thousandths compressed thickness. And since we had our best local machine shop, Shacklet Automotive, cut the deck straight to 9-inch, that combines with a 58cc chamber for a measured static compression ratio of 10.92 to 1. So, both engines will be within 1/100th of a point of compression from each other. That is close. The head bolts also receive thread sealer and are torqued to 65 pound-feet.
All of the valve train for both engines remains exactly the same, so the Ford bolt-down 1.7 ratio rockers are installed at TDC on each cylinder with high-pressure lube on the load points. The Chevy 1.6 ratio rocker arms and push rods are installed in a similar manner, with each cylinder's lifter being preloaded 1/2 turn past zero lash.
We were able to save some money and reuse the intake gaskets on both engines, so a bead of sealer on the china walls of the 305 is followed by the Vortex-specific 4150 intake that gets torqued in an X pattern in increments to 30 pound-feet. The 302 gets a matching RTV bead and its matching intake, which is tightened down in a similar fashion and also torqued to 30 pound-feet. Coming up, we're going to see if this bow tie has anything for that blue oval.
Okay, it is round 3 of the 302 versus 305 showdown, and we have our 302 Ford on first, and we got this thing basically ready to go on the dyno, and like we said before, all the other components on this engine are the exact same. I do think on this one, we should step up the RPM a little bit, so I changed it to 2,500 to 6,200 RPM at 300 a second.
I agree with all that.
All right, good. All right, so
Let her buck and see what it does here. It's going to be actually pretty good. Yeah, all right. Carried it out really nicely.
Definitely made more.
Oh yeah, look at that.
Okay. 348.7 pound-feet.
Yep.
Right at 4,700.
That's up.
And what was that 362.4?
Yeah.
At 6,100, and then it just starts to peak over. So that is solid. I mean, last time
Solid.
we made
That's
344 to 361.9. I mean, and that's a sizable gain for just one part change, basically.
And the one part change is 1.35 points of compression. Let's make another pull.
Yeah.
And I mean, I don't
Let's
think.
back it up real quick.
Yeah, that was a little better.
Yeah, 352.4.
364.2 horse pressures.
Dang! I mean, it's making over 300 pound-feet from 2,600 on.
How do you think the Chevy's going to stack up to it now?
That's going to be the interesting part. So let's get this one off, get that one on, see if we can do some same-day testing and see what happens.
It's always better to do it on the same day.
Yep.
All right, we got the engine swapped out. We have our 305 on the pump, and our 302 did extremely well. It did pretty much what we thought it should do. The whole idea with this is to get these back to the same level of compression, and we have done that. So let's heat this baby up and see what it does.
And so this one is jumping basically 2.3 points of compression,
Yeah.
which is a huge swing. The cylinder heads and induction package on this one is a little bit better.
Slightly better. People always think this has a tiny bore. It's not exactly tiny. It is within a very, very small amount of what a 4.8 or a 5.3 LS is, right?
Yeah.
Let's let her eat here and see what happens.
Go for it.
I already see similar torque numbers. Wow.
That was very close.
That was very close. I mean,
Yeah.
this one is pretty spicy.
Yeah.
345 pound-feet of torque and 359 horse.
Yeah, there's no, I mean, that's just huge gains. I mean, that right there, it's just say 4,200, whatever, just to pick one. That's 30 pound-feet,
Yep.
you know, and it's carrying that extremely well everywhere. So that's what I want to see. That's pretty cool.
Yeah, all right,
Just-
let's make another
All right.
rip on it here.
better, yeah.
How can anybody say this engine is a boat anchor? 359.9. I'm gonna go ahead and call that 360, right?
And 351.6 for torque.
Let's air that to the Ford.
Okay.
Wow.
See, that's pretty cool. So that is basically a direct overlay, interestingly, from basically, I'll call that 4,300 on. They're almost a direct overlay.
They're the same engine.
Same engine, but from 4,300 below, this Chevy is killing it. I mean,
okay, so what have we learned here, right? We learned that science doesn't lie, right? The engine doesn't know what brand it is, right? It knows its displacement.
We're not building F1 engines. You know, these are hot rod engines, right?
Right. Here's something that's gonna really anger anyone about the legendary DZ302, right? They make around 360s in the horsepower range, but they only make 330s for torque.
You could call this the budget DZ302, right?
You really could.
For a couple grand all in, you know, and you could have an engine that, will basically stomp one of those on torque and make similar power.
And suffice to say, we did what we were accomplished to do. We got the engines back on level playing field with similar parts, very similar compression, similar inductions.
Yeah.
They make virtually the same power.
And really sets the stage for maybe future upgrades. We got to figure out what we're going to do next.
We are going to have some future upgrades. So.
Yeah, great job.
Great success.